We are going to start soon. What are the shoes? Este está muy hard. No, me dice, hey, mami. ¿Cuál es Roblox, profe? ¿Cuál es Roblox? Roblox. Roblox. Creo que le voy a bajar un poco al teclado. Oh, vamos a ver. Ok. Oh, ok. Ok. En este momento estoy creando un programa. Un programa que me permite crear un camel case en un snake case. Es decir, el camel case es cuando tenemos esto, así, y transformarlo a esto. En vez de tener las primeras letras con mayúscula, poner todo minúscula y poner subguiones. Dice, ok, ok, ok. Ah, es raro porque yo ya sé qué hacer, pero no sé cómo, por dónde empezar. Creo que lo mejor sería que vea todos los videos de Harvard primero. A ver si hay algo nuevo que tenga que ver. ¿Qué es esto? I'm sorry.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on loops, this ability in Python and a lot of other programming languages to do something again and again, a cycle of sorts. And let's see if we can't begin by motivating exactly why we have this ability to do things cyclically using these loops. I'm going to go ahead here and open up VS Code. And in my terminal window, let's go ahead and create via code cat.py a Python program that meows like a cat. And I'm going to go ahead here in this code tab. Very simply, perhaps, I'm going to start by implementing this cat just by using prints. We're going to have this cat not make audible sounds, but just print meow, meow, meow on the screen 3 times. Well, I think the simplest way I can do this is just to print meow once, and to print meow again, and to print meow one last time on the screen. And now let me go down to my terminal window. Let me run python cat.py, enter, and meow, meow, meow. All right, so this program works. This program indeed works. If my goal is to get the cat to meow 3 times. And let me propose, just to help us wrap our minds around what's going on inside of the computer, let me propose that we consider this flowchart. So as before, we have this flowchart that starts with a this oval, which just means start reading here. And then notice it goes by arrows to a meow, 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 and then it stops. It's perfectly correct, and honestly, it's wonderfully simple, but I dare say we can find fault with my code nonetheless. Why is my code arguably poorly designed? Now, the answer is going to be loops in some way, but let's see if we can identify in what way the code is actually poorly designed in some sense. Let's see. Any thoughts, Alex?
Okay, so I mean, repeating the same action like 3 times or even more is not a good habit.
Yeah, I'm just repeating myself. And honestly, it's not that big a deal. If we go back to my code here, am I really doing such a bad thing by just printing meow, meow, meow 3 times? Not really, but let's consider the logical extension of this. Suppose I want to meow 4 times, or 5 times, or 50 times, or 500 times. Do you really think, even if you've never programmed before, is the solution to this problem really going to be to hit copy-paste 50 times? Probably not. We can probably do better than that. And beyond it just being ugly at that point, having so many lines of identical code, just imagine if you wanted to change the code. Maybe I changed my mind and I don't want to make a cat, I want to make a dog. So now it has to say woof, woof, woof multiple times. Now I have to change that in like 50 different places. And yeah, sure, I could do find and replace, but come on, like we're programmers now. There's got to be a better way than just repeating ourselves. So I bet we can do better than that if we think about a little harder how we go about structuring this program. And we can do that if we augment our vocabulary just a little bit. It turns out in Python, and in other languages too, there's a keyword called while. And while is one way that we can express what's called a loop, a block of code that's going to do something again and again and again, 0 times, 1 time, 2 times, 50 times, as many times as we want. But while rather leaves to us the particulars of how we express ourselves to do something again and again. So let me go back over to VS Code here, and let me propose that I do this. While is a construct that allows me to ask a question again and again. And anytime we've seen a question, it's been in the form of a Boolean expression, a question to which the answer is true or false. Well, how could I do this? How could I print out meow 3 times and ask 3 times a question to which the answer is true or false? Well, what if I did some counting, right? Like literally on my fingers, and if I'm trying to count maybe down from 3, I want to meow 3 times, I can put 3 fingers up, and I can meow, and then I can put like one of the fingers down, and then meow, and I can put one of the fingers down, and I can meow, put one of the fingers down, and maybe the question I can ask every time I meow is, do I have any fingers up still? Do I have any fingers up still? Do I have any fingers up still? And if the answer is true, keep going. If the answer is false, stop. So how can I translate that to code? Well, once we've added this while keyword, I think we have all the... yeah, Timo?
Hi, I think it's going to continue to print out mail since I is always equal to 3 and the while is always true.
Yeah, exactly. If I'm initializing I to 3, that is setting it equal to 3 on line 1, then I'm asking the question, while I does not equal 0, and that's going to be true. It does not equal 0, it obviously equals 3, print meow. And the way a while loop works is that the Python interpreter just keeps going back and forth. It goes from line 1 to line 2, then to line 3, and then it goes back to line 2 to ask the question again. If the answer's still true, it goes to line 3, then it goes back to line 2. If the answer's still true, it goes back to line 3. And to Timo's point, if you're never actually changing the value of I, it's always 3, you're just going to be looping literally forever. This is an accidental infinite loop. So we've got to be smarter than that. I'm not going to hit enter because I don't want to lose control over my computer here such that it's printing out meow forever. Fortunately, if you ever do that and you find yourself in an accidental infinite loop, Control C for cancel or interrupt is going to be your friend. If you ever seem to lose control, you don't need to like reboot or turn off the computer. You can just hit Control C in your terminal window and that will likely fix it. All right, well, what do I want to do then after meowing each time? I think what I'd like to do here is maybe something like this. Let me update I to equal whatever the current value is, minus 1 here. Whoops, sorry, minus 1. So if I, on each iteration, am updating I to be 1 less, 1 less, 1 less, it should eventually hit 0, at which point the answer to 9.2's question will now be false. So let's see if this works. I'm going to go down to my terminal window and run python of cat.py, and I indeed get 3 meows. Why? Because I've kind of wired this up, kind of like a machine in software, if you will. I've set I equal to 3, then I keep asking this question, but I keep turning the gears. I keep changing the value of the variable to make sure that ultimately it is actually being decremented, that is decreased by 1 until we eventually hit 0. Now, for those of you who think a little more graphically, let me pull up one of our usual flowcharts. This is just a representation graphically of the exact same thing. Notice what's happening. I first start the program, and then I initialize I to 3, and then I ask the first of my questions. Again, the diamonds always represent questions, and the answer is going to be true or false. Does I not equal 0? Well, it doesn't. It equals 3, so if I follow the true line, I meow. And then I follow this arrow, and I update I to equal I minus 1. At this point in the story, I presumably equals 2, mathematically. I follow the arrow, and there's the loop. This is why it's nice to see this graphically, perhaps, because you can literally see the loop back and forth. Now I ask the question again. Does 2 not equal 0? Well, it does not equal 0. It's 2, so we meow again. We change I from 2 to 1. Well, does 1 not equal 0? Well, obviously, if 1 is not 0, so we meow again. We decrement I again. I is now 0. Does 0 not equal 0? No, it equals 0, so the answer is false, and we stop. So there, perhaps more so than any of our flowcharts before, do you really see the structure of what's happening inside of the program. And you don't have to get into the habit of making these charts or creating these charts, but just as a first pass at what's going on inside of the computer, that's indeed one way to visualize it instead. Well, let me propose that, like always, there's many different ways to solve this problem. And suppose you just like to think a little differently. Maybe you don't like starting at 3 and then counting down to 0 y. Maybe your brain doesn't work that way and you prefer to count up instead of down. Totally fine. Let me go ahead and change my code here to set I equal to 1 instead of 3. And here, let me just change my logic. Rather than checking for not equal to 0, like maybe you don't like thinking in terms of not because it's a little confusing, and it might be, let's just check that I is less than or equal to 3. So we'll be a little more explicit. We'll count from 1 up through 3, each time printing meow, but I'm going to need to change line 4 for me. How do I want to change line 4? To be consistent with counting from 1 up to and through 3.
I would be plus 1 every time you meow.
Yeah, exactly. In this case, we want to add 1, not subtract 1. And in fact, if you think about this, this too could end very poorly, right? If you start counting at 1 and you keep subtracting 1, subtracting 1, subtracting 1, I think we're going to find ourselves with the same problem, which is that we're never going to stop because we're going to keep getting more and more negative as opposed to ever getting up to the number, namely a for loop. And this is a word that does exist in other languages, but doesn't necessarily express in expression. It's a fact set of items. Lines among exact loop, print it. We're going to go ahead or leave the random feels good. Many problems. That number is I can number loop. If you make like you do, whereby if I read. You have to be kind of a geek. Cool. If you want improvement or change there. But to really blow your minds intrigued by what's possible in Python, cat to meow 3 times, what if I actually do Python improvement or change there? But to really get you intrigued by what's possible in Python, I want the cat to meow, you have to be kind of get back exactly to me. Let me run python of cat.py, enter. Okay, it's a really like hungry cat or something. It's meow, meow is being repeated multiple again. Slash in there, inside of my quotes. I like this. Let me call in someone else. The only thing I don't like, and I know I'm being really nitpicky now, is that it's meow, meow, meow on separate lines, but there's kind of this extra blank line, which I'm just not loving aesthetically.
I think we can make in the equal.
Is that it's meow, meow, meow on separate cat.py. Go back, clean this up. Let's say resource. So now I type of 2, and it changed ever. Now, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got n equals quote unquote. So you don't have to line ending is. By default, it's \n itself, which is why at the very end of this print, the cursor is being moved again to the next line. Well, we need to just override that. So let me go into my code here and let me change this to end equals quote unquote, so that it's no longer the default \n. It's instead now going to be nothing whatsoever. That should eliminate then hopefully that additional blank line. So let me run this one last time here, Python of cat.py, enter, and there we have it. So now, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got n equals quote unquote. So you don't have to do things this way. My previous approach with a for loop, totally fine. My previous approach with a while loop, totally fine, and in some sense, perfectly well designed. But this is just yet another way to do it, but it's not a good thing if you or your tutor, your colleague, your friend are going to struggle to read your own code. But this is a feature of Python that some languages do not, in fact, have. All right, well, let me propose that things get more interesting still if we're not just meowing 3 times only, but we're meowing some variable number of times. Let's ask the user how many times this cat should meow. So let me clear the screen here, and let me figure out, well, how do I get a number from the user? The catch here is that if I want the user to give me a number, I'm not doing math per se, I'm meowing, and therefore the user has to give me a positive value. The user has to give me a positive value. So how can I insist on this? Well, if I just do this, n equals int of input, what's n, question mark, well, I want to check, like I could say if n is less than 0, like if it's negative, well, I could do this. Well, then ask again, int input, what's n, question mark. Okay, well, what if the user still doesn't give me a positive number? What if they're being really difficult, they're not paying attention, and they typed in 2 negative numbers? Well, if n is less than 0, well, let's do it again. N equals, right, this does not end well. You can't infinitely many times keep checking, is it negative, is it negative, is it negative, right? The program would never be done written. So we can do this, something better, listen to the loop. So let me propose this, a very common paradigm in Python, when you want to get user input that matches a certain expectation you have, that it's all positive, that it's all negative, or just something like that, you just immediately say while true. You deliberately, and a little dangerously, but very conventionally, induce an infinite loop. Now, what is an infinite loop? It's just one that goes forever. And we've seen how that can happen accidentally, mathematically. It's absolutely going to happen when you say while true. Why? Well, the answer to the true question is always true. So this is a way of deliberately inducing a loop that by default is going to go forever. So we're going to need a way of breaking out of this loop when we have the number we want. The convention, though, inside of this otherwise an infinite loop is to ask the question you care about, like give me an int by prompting the user for input, like what's n, question mark, and then just ask your question. So if n is less than 0, then I think we want Python to just continue to prompt the user again. That is, we want the code to stay in the loop, recall the input function, and hope that the user gives us a better answer if this time around it's less than 0. So let's just literally use Python's keyword continue, which says just that, continue to stay within this loop. Else, if it's not less than 0, let's go ahead and just break out of the loop altogether using another keyword in Python, break. Break will break you out of the most recently begun loop. In this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user, but I think we can tighten it up further so as to not bother having an if, and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0, so let's wait until they give us an integer that is greater than 0, and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before, and let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start with 3, where we began. Meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py, let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm. In Python when you want to do something again and again and again, but only until the user actually gives you a value that you care about here. And let me propose, actually, now that we practice a little more what we've been preaching, especially when it comes to, say, writing your own functions, now that I'm doing all this meowing, it might be nice to actually have a meow function that the inventors of Python didn't envision. So let me do this. Let me actually get rid of all this code, and let me go ahead and do this. Let me go ahead and say define a main function, as I've done before, and let me just blindly call meow3. Meow doesn't exist yet, but when it does, that'll be great. So let me go ahead now and define meow. So my meow function should take as input a parameter called n, or anything I want, and this part's pretty easy now. How do you meow n times? Well, for underscore in the range of n, go ahead and just print meow. So same code as before, nothing new here. I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, 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 it's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead now and maybe do this. let me ask the user for a number. So let's say something like this: number equals get number. All right. Unfortunately, there is no meow, but when it does, let's actually have a meow. Say, especially. Tighten it up further so it's not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0, so let's wait until they give us an integer that is greater than 0 and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before, and let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going begun loop, in this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user, but I think we can tighten it up further so as to not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0, so let's wait until they give us an integer that is greater than 0 and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before, and let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like, I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once indented, in cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start. Start with 3, where we began. Meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py. Let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm in Python when you want to do something again and again and again, but only until the user actually gives you a value that you care about here. And let me propose, actually, now that we practice a little more what we've been preaching, especially when it comes to, say, writing your own functions, now that I'm doing all this meowing, it might be nice to actually have a meow function that the inventors of Python didn't envision. So let me do this. Let me actually get rid of all this code, and let me go ahead and do this. Let me go ahead and say define a main function, as I've done before, and let me just blindly call meow3. Meow doesn't exist yet, but when it does, that'll be great. So let me go ahead now and define meow. So my meow function should take as input a parameter called n, or anything I want, and this part's pretty easy now. How do you meow n times? Well, for underscore in the range of n, go ahead and just print meow. So same code as before, nothing new here. I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, 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 it's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead now and maybe do this. Let me ask the user for a number. So let's say something like this: number equals get number. All right, unfortunately, there is no function in Python called getNumber that gets a positive number from the user, but I can invent that. So define getNumber, open paren, close paren, and then inside of this function, let me do this. While true, go ahead and get a number from the user, converting it in Python called getNumber that gets a positive number from the user, but I can invent that. So define getNumber, open paren, close paren, and then inside of this function, let me do this. While true, go ahead and get a number from the user, converting it to an int, asking them what's n, question mark, and then if n is what I want, it's a greater than 0 value, a positive number. I don't want to break this time necessarily, although I could. I instead want to return the value so I can actually do this instead. And this, too, is a feature of Python, this ability not to just break out of a block of code, but also to return a value in code, to to actually return a value gives you the ability ultimately to return explicitly a value so that your function has not just a side effect necessarily, but it actually hands back, just like input does, just like int does, just like float does, an actual value to the user. Now, to be clear, I don't have to return n here. I can still break out of the loop, as I've done in the past with code like this, but then after the loop, I still have to return n. And so what's happening here is that if you use break to get out of the loop, but you need to hand back a value from a function, you still have to use the return keyword now explicitly, either in the loop as I did, or now outside of the loop, but still inside of the function. The last thing I'm going to do here now is change that 3, which we hard-coded earlier, to actually be the value of the variable we've gotten from the user, so that now down here, if I run Python of cat.py, enter, what's n? I can type in 3, I get my 3 meows, or if I only want 1, I now get 1, as I've done before. Let me just blindly, so my how do meow enter, I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, 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 it's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead and get a number from the user, converting it to an int, asking them what's n, question mark, and then if n is what I want, it's a greater than 0 value, a positive number, I don't want to break this time necessarily, although I could. I instead want to return the value so I can actually do this instead. And this too is a feature of Python, this ability not to just break out of a block of code, but also to return a value in code. To actually return a value gives you the ability ultimately to return explicitly a value so that your function has not just a side effect necessarily, but it actually hands back, just like input does, just like int does, just like float does, an actual value to the user. Now, to be clear, I don't have to return n here. I can still break out of the loop, as I've done in the past with code like this, but then after the loop, I still have to return n. And so what's happening here is that if you use break to get out of the loop, but you need to hand back a value from a function, you still have to use the return keyword now explicitly, either in the loop as I did, or now outside of the loop, but still inside of the function. The last thing I'm going to do here now is change that 3, which we hard-coded earlier, to actually be the value of the variable we've gotten from the user, so that now down here, if I run Python of cat.py, enter, what's n? I can type in 3, I get my 3 meows, or if I only want 1, I now get 1 meow instead. All right, so if we now have this ability to do things again and again in these loops, let's see if we can't solve some other problems via which to express ourselves cyclically, but get back some interesting answers as well. Let me propose, for instance, that we look a little more closely at these lists. It turns out that in Python and really in programs in general, it's useful to have a list of values because we're going to be able to work with more and more data, larger and larger data sets. So let me propose that we come back to VS Code here, and let's do something that's perhaps a little familiar to some folks, the world of Hogwarts. And let me go ahead and code up a file called Hogwarts, and let's see if we can't have a list of students at Hogwarts here. So I have a new tab called Hogwarts.py, and let me go ahead and propose that I just define in this program a list of students whose names I know in advance. So I'm not going to get user input for now. I'm just going to know from the get-go that the 3 students I want to consider are these. A variable is going to be called students. It's going to equal, as I've done in the past, a square bracket, which means, hey, here comes a list. And those values are going to be Hermione, in quotes, because it's a string, Harry, in quotes, because it's a string, and then Ron, in quotes, because it's a string as well. So this is a list of length 3. It's similar in spirit to my list of length 3 earlier, but that had 3 ints, 0, 1, 2. Now I have a list of 3 strings instead. And this isn't very useful at the moment, but let me just do something as a check for myself. Let me print out each of these students. Well, wait a minute. How do I print the contents of a list? Well, in the past, when we printed a variable, we've just printed out the name of the variable. But I don't want to print out all of Hermione and Harry and Ron all at once. Maybe I want to print out Hermione first, then Harry, then Ron. So I need a way to express more precisely which value do I want from this list. And the way you do this in Python is you use square brackets in another way. If you have a variable, in this case called students, and you want to go inside of that variable and get a specific value, that is to say you want to index into the list, you use square brackets this way using numbers inside of the square brackets. And here's where we see that it is useful to think and count in terms of 0 on up instead of 1 on up. These lists in Python are, shall we say, 0 indexed. The first item in a list is at location 0. The second item in a Python list is at location 1, and the third is at location 2. So you're always kind of off by 1 mentally, but you get used to it if you've never programmed before over time. So let me print out all 3 students. So let me print out students bracket 0, then students bracket 1. Then lastly, let me print students bracket 2, and this is my third and final line. And of course, if I run this code, it probably does what you would guess. If I run Python of Hogwarts.py, there's Hermione, Harry, and Rob, each on their own lines there. But there's got to be a better way, right? Especially if I don't know in advance who's going to be in this list. If next year there's some new students at Hogwarts, we can use a loop to do something automatically without having to manually type out 0 and then 1 and 2. Well, here's another feature of Python. You can use a for loop, not just to count from 0 to 1 to 2. You can use Python to just iterate over anything, not just numbers, but strings. So I could actually do this. For student in students, colon, and then indented underneath that, I can say print student. Now, it doesn't matter if I have 3 students or 4 or 400. This 2 lines of code, this loop, will print all of those students for me one at a time. So if I now run Python of Hogwarts.py, there's the same list. but I don't need to know in advance how long that actual list is. Now notice I made a conscious decision here. I didn't call this variable underscore, because this time I'm using the variable. And while I could do this, now, no. Your code is getting way too cryptic. If you're naming the variable underscore and you're using the variable underscore, now you're helping no one. Now you're confusing the reader yourself down the line. You should call your variables what they are. So a very appropriate name, though I'm sure you could come up with others, would be student, and here you would say student as well. If you prefer to be more succinct, it's not unreasonable to do something succinct in a loop like this. For S in students, using maybe the same letter that the list itself begins with, but again, why bother? Python is meant to be more readable. If you have a list of students, iterate over them one student at a time. Let me pause here to see if there's now questions about lists, as I've now defined them, a list of strings in this case, or using a for loop now to iterate over and print each of those names.
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused on exists and it will work. Other questions on Harry's question?
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused only on break.
Okay, sure. Can this follow work with either hash tables or different kind of iterables or arrays?
Indeed, so we're getting ahead of ourselves there, but there are yet other types of data in Python, and indeed, you can use a for loop to iterate over those as well. Anything that is iterable, so to speak, is a piece of data that can be used with a loop like this. But more on those soon. In fact, let me transition here to show just another way of solving the same problem, because up until now, when we've used loops, we really have relied on numbers, and that's fine if you prefer to sort of stay in that space. Suppose I did want to iterate using numbers, like I, and 0, 1, 2, and so forth. Let me propose that we could change this code as follows. If you would prefer to think about, or if the program you're trying to implement requires that you use numbers like this, you might do this. For I in, well, I don't want to just say students, because then I is not going to be a number. I is going to be literally Hermione, then Harry, then Rob. I need to iterate from 0 to 1 to 2, right? If I know a list with 3 elements, has these locations, 0, 1, 2, I need to create a loop somehow that starts at 0 and ends at 2. Previously, when I wanted to do that, I needed range, but this 2 is not going to work. I can't just say in the range of students, because students is not a number. It's not an integer, so you can't pass it to range. Range expects an integer. But there is a solution here. It turns out that there is a function in Python called length, or len, L-E-N, that will tell you the length of a list, and other things down the line too. And now I think I can assemble these building blocks in a way that can allow me to use numbers in this way. So range doesn't take a list of strings, it takes a number. And ideally that number is going to be 3, so I get a range of values, 0, 1, and 2. So I think I can nest my functions like this. If I first get the length of the student's list, that's going to be 3. Then I pass that return value as the argument to range. That's going to give me back a range of values, 0, then 1, then 2. And what that's going to allow me to do then in code if I want is not just this. I could do print now students bracket I. And this is now where the syntax we're seeing is getting very expressive, new, and perhaps unfamiliar. But if I can do open bracket 0, close bracket, or open bracket 1, close bracket, or open bracket 2, close bracket, turns out I can actually put a variable in there, and I can express any number inside of those brackets so as to print these all out dynamically in a loop. Let me do this. Python of Hogwarts.py, enter, there's Hermione, Harry, and Ron. And now if I'm just curious, if I just want to poke around, or maybe I want to do a ranking, like who are the top 3 students in the school or in Gryffindor, well, I can print multiple things at a time we've seen. Let me print out not just the students at location I, but rather let's print I first, and then the student at location I. So 2 things to print, and we know that print can take 2 arguments. We've seen that before. They'll be separated by a space. Let me go ahead and rerun this. Now I see that, okay, Hermione is the top student, but she's in 0th place. That's a little weird. Like, we don't need to show the human using my program that we started counting at 0. I can clean this up. I can just add 1 to the I up here, and now we see sort of a top 3 list of students. Hermione's number 1, Harry's number 2, and of course Ron is number 3. So we can get access to all of those same values as well. Are any questions now on these lists? Any questions now on these lists? This length, these ranges, or otherwise?
My question is, for I in range, can you explain this once more?
Sure.
Still looks cryptic.
So let me rewind in time. We started off doing this, for I in 0, 1, 2, and then we printed out meow 3 times in that way. The way that the for loop works is that it creates for you a variable that I've called I, but I could call it anything I want. It then assigns I initially to the first thing in the list. It then automatically assigns I to the next thing in the list. And then it assigns I to the third thing in the list. And each time, it does all of the indented code underneath. We realize, though, that this is not going to scale well if I want to do something like 1,000,000 times. So we introduce range instead. That has the effect of doing the same thing. It returns to me a range of values, a list of 3 things, really. So the behavior is exactly the same. If we now fast forward to this Hogwarts example now, though, what I'm doing is just combining these smaller ideas. I'm still creating a for loop. I'm still creating a variable called I. I want to do it over a range of values, but how many values? Well, if I use the length function and pass to the length function the list of values, length's purpose in life is to tell me how long is this list, and it's 3. So that's almost as though before I had just done something like this, but I don't want to hard code 3. I want to dynamically figure out how many students are at Hogwarts. So I'm just composing, or nesting all of these various ideas. All right, if I may, let me transition now to Hogwarts still to introduce one final type of data before we combine everything with a few final programs. It turns out in Python, there's not just strings, not just ints, not just floating point values, not just bools, not just lists. There are also what are called dictionaries, or dicts, which are a data structure that allows you to associate one value with another. Literally a dictionary, like in the human world, if you were to open a dictionary, be it in English or any other human language, what's inside of a dictionary? Well, it's a bunch of words and definitions. A computer scientist, though, and a programmer would describe those more generically as keys and values, something associated with something else. That's all a dictionary is. It allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of two-dimensional, if you will. Just like a human dictionary, a book, it associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well, I could do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house. And let's add Draco in there, so we now have 4 instead of 3 students, just so we have a little variety, and he was in Slytherin. So now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Whoever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want to keep track of more things than that? What if we want to keep track of every student's house and the Patronus, this image that they conjure up magically? Well, then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. A student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here, and let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings, completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students, and let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here. But notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea, a little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes, to get inside of them. So if you want to print out Hermione's house, the key you care about is quote-unquote Hermione, and what this syntax here will do, notice it's not a number 0 or 1 or 2. It's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote-unquote Harry should give me Harry's house. Print student Draco's house. Now, it's a little manual still. I bet we can improve this, but let me run Python on Hogwarts.py, and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now, all we've done, again, is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values, respectively. Allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop, and this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So So this is not going to be that interesting yet, but when I run python of hogwarts.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now, when I'm doing for student in students?
Yeah, I think we will only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses, but when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now, enter, and indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. Can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary, right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house, and the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do python of hogwarts.py enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space comma, and just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not in fact Gryffindor, but that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does if I'm just correct me if I'm right, does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry, and Ron, as the indexes in the actual the list of students?
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable's called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2, it allows me to, for instance, set student equal initially to Hermione's name, and then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their patronus in this case. Well, what might code like this look like? Well, let me go back to hogwarts.py, and let me start fresh for just a moment, and let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students, and suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else. Well, here's one other way we can do this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, one dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that one key this time won't be the student's name explicitly. It will literally be the word name, and they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And the same student is going to have a third key called patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Book, patronus, the patronus is going to be, in this case, a stag. All right, and terrier. Lastly, is this as keyword in Python that is literal in the books or the movies. So it turns out, this is actually a wonderful teachable moment, there is a special keyword in Python that is literally none, N-O-N-E, with the first letter capitalized. This represents officially the absence of a value. So I could, a little sloppily, do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. Okay, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know That is a dictionary, a collection of key-value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key-value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and Otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design, that's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students, and I can still do a loop. I can say, for student and students, that's going to allow me to iterate over this list of students, and let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary, looking up the word name, and giving us Hermione, Harry, Ron, and Draco respectively from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione, Gryffindor, Harry, Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus. And then the values of those keys can actually be the data, like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof.
I just was wondering if suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language, that is a feature of a dictionary to get you the data quickly, and there are functions that you can use. You can sort the data, you can sift through it, you can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up was this one here on the original Nintendo. And this is a 2-dimensional world where the characters move up, down, and right, not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked on top of one another, and we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually, using maybe just hashes for bricks. Because there's a pattern here, one on top of the other, and I bet the base version of this textually, using maybe just hashes for bricks. Because there's a pattern here, one on top of the other, and I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here, and let me propose that we create a program called Mario.py using code in the terminal window. And then up here, let me start by implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run Python Mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe these the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned and instead do something like this. For underscore in range of 3, let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code too, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse, they allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does, not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called print column. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, print column, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called print column. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run Python of Mario.py, we're back where we began. But I now have a function, an abstraction print column, that's going to allow me to think about printing some chunk of the world of Mario at a time. And I can do this in different ways too. Notice that if I really want, I could do something like this. I could re-implement now print column in different ways, especially if I'm using print column all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my print column function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement print column, recall, would be something like this, a bit clever with one hash and then a new line, and then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's okay if you're not comfortable with this syntax. This was a more clever approach we saw in the past, but if I run Python of Mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of print column, this simple, I think are going to be more sophisticated problems. And if some underlying those question marks for what could otherwise be a loop, and that's fine, but this is going to go ahead and print those question marks for me. Let's do Python of Mario.py, enter, and now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having print column and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this, or with the column version, but what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's two-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3x3 grid, a 3x3 square of sorts. Well, how can we go about solving this here problem? Well, let me propose we come back to VS Code, and let me propose that we think about this in a couple of different ways. I could do this,
Bueno, muchas gracias por acompañarme a todos. Pasen muy bien.